Hi, 8th grade. So we are going to start lesson 3. We are on the Dear Family page 43. We're not going to talk about the Dear Family too much, but as I'm recording this in the future from you guys, today we just had a lesson where Addie asked about can a shape reflect and then translate? And yes, that's called a multi-sequence of transformations. So that's what we're going to be learning about. We're going to be learning how shapes can not just translate, but they can translate and then they can flip and then they can move again. So look at the picture on 44. It says, have you ever rearranged furniture in a room? When you move a chair from one side of the room to the other, this can be described as a sequence of transformations. Okay? So as you can see in the living room before, we got the couch, the 2 chairs, the coffee table, and then it looks like the couch moved, the 2 chairs moved, the coffee table moved. But it's more than just like a move, because if you look at the couch like slid up and then it rotated, and then the 2 chairs, there was maybe some sliding and maybe some reflecting, and then the coffee table rotated. So there's so many ways that a shape can move, and that's not just one way. How many ways can you describe the movements of the furniture between the before and the after pictures? So just go ahead and pause the video right now, take some time, just see what you can do. How would you describe the movements here? I mean, maybe you would say that the couch didn't translate and then rotated. Maybe you just say that the couch completely rotated into that spot. Maybe you would say that this chair slid over, and then maybe this chair slid down and then it rotated or it flipped in its spot. Okay, so come up with a whole bunch of different ways that you can describe the movements of that furniture. I'm going to go ahead and go on to the next page. So now we're on page 45, lesson 3, session 1, and we are going to be talking about how to perform and describe rigid transformations that happen more than once. Okay? Let's go ahead and read the example. Oh gosh, why do they pick names like this? Like, why can't we just be like Jill? Okay. Arachnes? Okay. Arachnes quilt is an Amish quilt pattern made of polygons. Remember, a polygon is a many-sided figure. You can use a coordinate plane to plan a quilt. Graph a pentagon with the vertices, this. Then, to graph another pentagon, follow these steps. Okay, so first let's go graph the pentagon. All right, it says A is 8, 0. Let's see here. Is there any negatives? There are some negatives. All right, so I'm going to go ahead and just draw me a coordinate plane, I suppose. Hopefully I don't run out of room. Let's see, I'm trying to plan this strategically. Okay, so this is my x-axis, this is my y-axis. Here's 0, 0. Okay, so A is going to be 8, 0, so I'm going to go over 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to change my colors here and do some red. Okay, so there's A. B is 6, -2. 1, 2, 3, 4, 5, 6, 1, 2. C is 6, 6, so this was over 6. Now we're going to go down 6. 1, 2, 3, 4, 5, 6. Oh boy. Okay, and then, better label that. C is 4, -4. 1, 2, 3, 4. Down 4. 1, 2, 3, 4. And then E is 4, 0. 1, 2, 3, 4, 0. Okay. Now I'm going to make my pentagon. Oof, this is a weird looking pentagon, I'll tell you what. Okay, ta-da. All right, now we can go read the rest of the directions. I want you to translate the pentagon, A, B, C, D, E, 4 units to the left and make A, B, C, D, E prime. Okay, so what we're going to do is we're going to take each of these points and just move them 4 to the left. Ready? So we're going to start with E, 1, 2, 3, 4. So here's new E, E prime. A goes over 1, 2, 3, 4. So new A is on top of E. B, 1, 2, 3, 4, new B. D, 1, 2, 3, 4, new D. And then C, 1, 2, 3, 4. Okay, now we'll connect them. Okay, so now we've got A, B, C, D, E prime. Now what's the direction say? Rotate the pentagon 90 degrees counterclockwise around the origin to form pentagon ABCDE double prime. Okay, so counterclockwise means we're going to go this way. Okay, let me erase my line. And we're going to do it 90 degrees around the origin. Okay, luckily, if we're going around the origin, E prime is on the origin, which means we're going to pivot on E, which makes this actually pretty easy to do nicely, because what we're going to do is we're just going to take this shape and we're just going to move it up here. So A is going to lead the way. A is going to go boop, 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 and A is just going to land right up here. I know A is going to land right there because, oops, I erased my lines. I know A is going to land there and not like up here by 1, because look, it's 1, 2, 3, 4 over. It's going to go up 1, 2, 3, 4 as well. So new A is going to be there. I should do these in a different color. New A is there. So A led the way. New E is still right here. Okay? So A and E are still there. Now B looks like it's diagonal 2. So I'm going to go diagonal from here 2. So new B would be about right here. Okay, do you see how that is diagonal? Just like the corresponding side right there is diagonal. And then from B to C, it goes over 1, 2, 3, 4. So I'm going to go over 1, 2, 3, 4. Here's new C. Okay, and then from there, it's diagonal backwards. So I'm going to go backwards 2, just like from C to D is. And then D to E connects. Oh my goodness, we did it, you guys. Wowza. We rotated that shape 90 degrees about counterclockwise. Okay, now what do we need to do? Is pentagon ABCDE double prime the same size and shape as pentagon ABCDE? Well, yeah, of course. It's a rigid transformation. Just because we transformed it twice doesn't mean that it's a different shape and size. So we're going to say yes. It is still a rigid transformation, and the corresponding sides are still the same length. Okay. All right. Now, I believe we're going to have some questions to answer now. So it says, look back. Is pentagon ABCDE double prime the same size and shape as pentagon ABCD? Explain. Okay, I'm not going to explain because I literally just wrote that right here. So this is going to go on the other slide, which this is ridiculous. I'm not going to rewrite that twice. I'm just going to say, look on page 45, because that's silly. Same question. You already know that you can transform a figure. You can also transform the image of a figure. Remember, that's the copy. You can transform the copy of a figure. This is called performing a sequence of transformations of a figure. You can add a prime mark to the vertex labels for each transformation you perform. So for example, if I were to now transform ABCDE double prime again, then I would put like a triple prime, okay? So the more marks means the more it transformed. How many transformations were performed to get this? Triple prime, triple prime, triple prime. So how many transformations happened? 3. I know that because there are 3 prime marks. So if it says explain, okay. Figures that are the same size and shape are congruent. When a figure is translated, reflected, and rotated, the image is always congruent to the original. That means that ABCD and ABCDE prime are congruent. We can write congruent with this fun little thing. It's like equal, but then it's like wavy. So it's like, yeah, congruent, okay? You can read that symbol as congruent too. So if you see ABCDE with that sign, you would say congruent to ABCDE prime. Write a congruence statement for pentagons ABCDE double prime and ABCDE prime. So I'd go A, B, C, D, E, and then everything's double prime, is congruent to A, B, C, D, E prime. Enrico translates figure Q to get figure Q prime. Then he rotates figure Q to get figure Q double prime. Explain why figure Q and figure Q double prime are congruent. It's still the same shape. Just because you transform it more than once doesn't mean the shape is changing. And reflect. How can you use a sequence of transformations to show that one figure is congruent to another? Well, by using the congruent sign, and you can use the prime markings, right? Prime markings mean it's the same shape, it just moved however many times, okay? That's all we're going to say because I feel like that's pretty self-explanatory. Now, we are going to do pages 47 and 48 in class. I do want you to scan this last page, 46, and upload it. All right, guys, see you in class.